Hello and welcome to all aspiring and established IT professionals. Today we'll explore the world of content delivery networks or CDN. What is a CDN? Why should developers, architects, and company CEOs all take advantage of it? Let's take a look. Content Delivery Network, for short CDN, came into existence in the late 1990s. It was initially developed to speed up the delivery of static HTML content and downloadable objects for Internet users all around the world. CDN has evolved over the ensuing decades. Nowadays, a CDN should be used whenever HTTP traffic is served. Why? Let's take a closer look to what a modern CDN can do for us. At its core, a content delivery network or CDN optimizes the delivery of content by minimizing the distance to the end user. This enhancement in proximity significantly elevates the performance metrics of a web service from the user's perspective. There is ample evidence to suggest that such performance improvements are pivotal for maintaining user engagement and retention rates. To enhance user proximity to services, CDN technology deploys servers across numerous global locations, termed as points of presence or POPs. Within these POPs, servers are specifically referred to as edge servers. The strategic distribution of multiple POPs globally ensures that users everywhere have access to a proximal edge server, optimizing speed and efficiency. Most CDN providers offer their services through a varied and defined array of POPs, tailored to desired coverage levels, including but not limited to regions such as the United States, international or global, Asia-Pacific, etc. These collections of POPs are sometimes designated as edges, edge nodes, edge servers, or edge networks, representing the nearest point of CDN infrastructure to the end user. Performance optimizations in content delivery networks or CDNs have been advanced through DNS extension mechanisms. Conventionally, the routing of CDN requests is influenced by the geographic location of a client's DNS resolver. This conventional method may lead to performance inefficiencies when there is a significant discrepancy between the resolver's location and the client's actual geographical position. For instance, a client in India utilizing a DNS resolver based in Singapore could inadvertently be directed to a Singaporean edge server, notwithstanding the presence of geographically nearer alternatives, thus compromising performance efficiency. That's the reason CDNs employ various methodologies to direct user requests to the nearest point of presence, primarily through DNS-based routing and anycast technologies. In DNS-based routing, each POP is assigned a unique IP address. User requests for the CDN's IP address are resolved by DNS, which returns the IP of the closest POP. Conversely, anycast assigns a singular IP address to all POPs, routing incoming requests to the nearest POP based on network proximity. These points of presence may function as caching servers, reverse proxies, or application delivery controllers with the capacity to distribute petabytes of content. Static contents are cached on the edge server in this content cache. If a piece of content is in the cache, it could be quickly returned to the user. Since the edge server only asks for a copy of the static content from the origin server if it is not in its cache, this dramatically reduces the load and bandwidth requirements of the origin server cluster. CDN providers like AWS accelerate dynamic content delivery and APIs. Optimized dynamic web content delivery. Developers can build powerful web applications at the edge that automatically scale up and down, with zero origin infrastructure and administrative effort required for automatic scaling, backups, or data center redundancy. On the edge location, you can improve search engine optimization, SEO, for your website by using serverless technologies. For example, you can trigger a serverless function to deliver a pre-rendered HTML page stored in Amazon Storage or S3 when the user agent is a search engine bot such as Googlebot or Bingbot. Serverless functions can help you block unwanted bots at the edge and let the authorized traffic go through. By intelligently mitigating these automated processes, developers can help protect your origin infrastructure from unhelpful web crawlers and bots while improving performance for real users. Architects can customize users' experience by transforming images on the fly based on the user characteristics. For example, you can resize images based on the viewer's device type, mobile, desktop, or tablet. You can also cache the transformed images at edge locations to further improve performance when delivering images. The edge server occupies a critical position within the modern security HTTP architecture by terminating all TLS or transport layer security connections. Given the computational overhead associated with TLS handshakes, particularly with prevalent versions like TLS 1.2 and 1.3, which necessitate multiple network round trips for establishment, the practice of terminating TLS connections at the edge server substantially minimizes the latency involved in initiating an encrypted TCP connection. This efficiency underpins the rationale for routing even dynamic, non-cacheable HTTP content through CDNs in many modern applications. It's noteworthy that the data transmission between the data center and CDN remains encrypted and is facilitated through a singular, secure channel. In addition to performance enhancements, contemporary content delivery networks or CDNs offer two principal advantages: security and availability. Security. Contemporary CDNs possess extensive network capacities at their edge locations, a critical attribute for mitigating distributed denial of service or DDoS attacks. By maintaining a network bandwidth substantially exceeding potential attack volumes, these CDNs effectively neutralize threats. This mitigation strategy is particularly efficacious in CDNs utilizing anycast networks, which distribute attack traffic across a vast array of servers, thereby diluting its impact. Availability. The inherently distributed architecture of modern CDNs significantly augments content availability. By replicating content across multiple points of presence, CDNs ensure resilience against hardware failures far surpassing that of original hosting servers. This redundancy ensures continuous content availability, even in the face of individual server or network segment failures. Security and privacy consideration. A website using a CDN may violate the EU's General Data Protection Regulation or GDPR. For example, in 2021, a German court forbade the use of a CDN on a university website because this caused the transmission of the user's IP address to the CDN, which violated the GDPR. In summary, content delivery networks or CDNs optimize global content delivery, reducing latency for enhanced user experience. Modern CDNs secure, scale, and customize web services, offering performance, security, and availability advantages. Security and privacy considerations are crucial, with GDPR implications. Thank you for joining me in this exploration. I hope this discussion will elevate your IT journey and fast-track your career in software development. And don't forget to like, subscribe, and hit the notification bell to get ahead of more cloud computing snippets.